Okay, here's a question from the June 2010 paper, and it's clearly a forces question, so I have to read it. It's in equilibrium, so the resultant force is going to be 0. The words are really just telling me what's in the diagram, so I have to do the resultant force and make it 0. So the resultant force is going to be these three forces added together. So I need 3 column vectors. There's going to be one very easy one, 0 minus mg. Okay, this is part I am doing. Plus 2 more forces that need resolving. So there is a 60 Newton force, okay, with an angle of 48 degrees. Okay, let's resolve that one. So I've got my 60 and my 48 degrees angle. This is in the positive x and the positive y direction, so I do not need any minus signs. I've just got to decide where to put the sign and the cos. Well, the 48 degree angle between the force, that cuddles up round to the x-axis, so therefore that is a cos on the x one, and the y one gets the sine. So I've done that one, and the other one is a 50 Newton force, 50 here, 50 here. This time the angle is theta, which I don't know. Never mind, I'll find it, I expect. So I've got those. Now, in the x direction, I'm going negative, so I need a minus sign here, but the y one is still positive. Okay, because it's going up. So, which one gets the cos? Well, once again, the angle theta is cuddling around to the x direction, so the x gets the cos and the y gets the sine. Okay, and it's in equilibrium, as we said at the very start, so the resultant force has to equal 0, 0. Okay, good. So now I need to find theta, and it said resolving horizontally. That just means I use my x line. Don't worry about the y line, we're going to use it later. So x implies that 60 cos of 48 degrees, I can add this to both sides, actually equals 50 cos of theta. So cos of theta equals 60 cos of 48 degrees divided by 50, and I work that out and inverse cos it, so that implies that theta equals 36.59 degrees, or we can just round that to 36.6 degrees. 1 decimal place of degrees is normally fine. Now in part B, we've got to find m. Well, the thing we haven't used yet is the y line, so let's see what that tells us. Y tells us that minus mg, oh, it's got an m in it, that's good, plus 60 sine of 48 degrees plus 50 times sine of my theta equals 0. Well, now theta's known, so mg is going to equal, okay, 60 sine of 48 degrees plus 50 sine of 36.6 degrees, which I've still got on my calculator. So m equals all of that, 60 sine of 48 degrees plus 50 sine of 36.6 degrees, all divided by g, which is 9.8. Lob it all in your calculator. The final answer of 7.59 kilograms, and that's that question done.